So I want to talk a little bit about formulating a DNA testing plan. So a DNA testing plan is essentially testing with a purpose. And the real goal here is to identify a person we would like to test for some specific reason. So the problem with giving a talk like this, of course, is that our specific reason will almost vary completely from person to person. So it's not as if I can stand up here and give you an exact targeted testing plan for whatever you want to put in place, whatever answer you want to whatever question you want to answer. So instead, I want to give you some sort of general guidelines for testing individuals for some of the reasons we like to test people. And I think of this as being two approaches. We can have a broad approach, and we can have a more targeted approach. The broad approach is testing multiple close relatives on different lines of your family. And the reason that we want to do this whenever possible is we can find matches they have that we don't have. And we'll dive into that a little bit more. And also to find these matches in shared match groups. So our targeted approach, however, is to use targeted testing to typically to answer a specific hypothesis or to create a focused shared match group that points towards a particular ancestral couple. All right, so I want to dive into these approaches a little bit and give you some ideas about finding individuals that are proper to test for your specific purpose. So when we talk again about the broad approach, we're talking about multiple close relatives on different lines. And so having tested relatives on different lines gives you several things. First of all, it gives you pieces of DNA that you share with those individuals that you can add to a chromosome map, for example. And that was sort of the focus of yesterday's talk. But it will also, again, give you people to find in these shared match groups. As you probably know, if you've heard me talk before, if you've seen my writing, you know I'm a huge proponent of shared match work, whether automated or manual. These shared match clusters are incredibly powerful, and I think are probably amongst the most powerful tools we have as genealogists. So a shared match group allows you to see matches you share in common with another person, and including in that list will be relatives that we know if we have tested multiple relatives on multiple lines, as I said before. So to show you an example, this is a new match, Cheryl Thomas. And Cheryl Thomas, here as you can see, she has one person in her tree. So if I can't figure out who Cheryl Thomas is, if I can't figure out what her tree is or anything like that, I'm kind of stuck working with Cheryl Thomas. On the other hand, if I can see the matches I share in common with Cheryl, that will give me an instant hypothesis about our relationship. So for example, what I will do is I will click on Cheryl's match page and I'll scroll down to see the matches we share in common. So here we share Nancy, Elizabeth, and Sarah, and so on. And what that means is that I can use these shared matches to potentially identify how I'm related to Cheryl. That's only if, however, I can discover something about these shared matches. So if I know something about Nancy or Elizabeth or Sarah, that allows me to hypothesize about Cheryl. Now, in this case, I have a known cousin as the first shared match. And so I know how I'm related to this known match, which allows me to form that instant hypothesis. The instant hypothesis about a group like this is that we all share common ancestry. That's how these shared match groups are created. The secondary hypothesis we can formulate from this is solely because I have a known individual in this list, and that is that we all are related on this line that I share with this known match. So if you think about it, as I look at more and more people and find more and more of these shared match groups, the more close relatives I have tested, the more they're going to appear in these shared match groups, and therefore the more I can make that secondary hypothesis about our mutual relationship. Now, what do I mean when I say close relatives? Well, it doesn't need to be things like siblings. In fact, siblings won't actually help you out too much with this because you share all of your lines with a sibling. It can be things like an aunt or an uncle or a first cousin or a second cousin and so on. It can be any sort of these relationships that allow you to point towards a particular line. And the more of these individuals you have, the more they're going to show up in these groups. So having known tested cousins is going to help you identify these unknown matches like Cheryl Thomas as they come in. And I mentioned this briefly yesterday, but now what I would do with Cheryl Thomas, I don't know what our exact relationship is yet. But at least I've narrowed it down to a particular line. And that particular line is whatever line I share with this known match, Nancy B. So what would I do? I would put in the notes field for Cheryl Thomas based on shared matching related through this line or whatever you would put in that notes field. But as I mentioned yesterday, it's like ripples in a pond. Now when Cheryl Thomas shows up in a shared match group, right, then she can help me identify potentially the identity of the ancestry of that shared match group. So the more people you have tested, again, the more you're going to be able to take advantage of this. And because we're not focused on a specific problem, we're simply looking to find these matches randomly when we have a new match come in, then that's why we want to try to find it on multiple lines. Right? Because we want to have these known tested relatives because we never know when they're going to show up in these shared match groups. And certainly we want to cast a net as wide and as big as possible. So the way I think of this is, first of all, we test ourselves. That's how most of us get started with DNA testing, right? We test ourselves. But the best approach after that is to test vertically. You want to test, if whenever possible, you want to test a previous generation. And then once you've exhausted that previous generation, then you want to test horizontally. Now, you can do both at the same time, but it's really important that you focus on that vertical generation whenever you can. And so when we talk about this, we often say you want to test the oldest generation that you can. Now, horizontal testing is typically testing as many relative cousins as you can. And that gets back to the broad approach we were just talking about. Lots of different lines so that they show up in shared match groups. Now, the reason you want to test that oldest generation is because you have these two family trees. And these two family trees, you have a genealogical family tree and you have a genetic family tree. So when we talk about our genealogical family tree, it is the tree of all of our ancestors. So if you could, you'd be able to fill in a name for every single one of these blocks, right? We know there is a person that goes into these blocks. Now, maybe here in the Netherlands, that might be more possible than it is in other areas. I certainly can't fill in all those names. I do know, however, there is a name that goes inside every one of these boxes. And every decision every single one of those people made ultimately led to me being here today. On the other hand, when it comes to a genetic family tree, this is a subset of your genealogical family tree. And that's because you can't have DNA from all of your ancestors, right? If you were, you'd just be DNA and nothing else. You'd be a big blob of DNA. And since that's not the case, you're only grabbing pieces of DNA and smaller pieces further back in time until you get to the point where you say, I can't get any more from you, so I don't get DNA from that line, and I don't get DNA from this line. Now, this isn't how your genetic tree would look like. Everybody's genetic tree is going to be different because we grab those pieces randomly. But if this were my tree and I'd reconstructed it, you can see the individuals in gray here are the people I did get DNA from, which means the ancestors in white are ones that I'm missing, ones I'm not getting DNA from at that generation. Somewhere around 6 to 8 generations or so, we start to lose genealogical ancestors from our DNA. And so the downfall of that, the problem with that is many, but one of them is if you happen to take a DNA test because you had a specific question about a line in this range, there's a possibility you didn't get any DNA from that particular ancestral line. And so if you think about it, if somewhere around 6 to 8 generations you're losing DNA from your genealogical tree, this is sort of what I think of as being the risk zone. Right? This kind of generation is where it's risky. Maybe you got DNA from that generation or that ancestor, but maybe you did not. And this is one reason why we want to test a previous generation. Because if you can test a previous generation, you can get that one generation further back, that risk zone. So it moves that risk zone from this range. If you can push it back another generation further. Now, people often think when I say test vertically or test a previous generation, they just automatically go to parents and they say, nope, no parents, so I'm done. But that's not the only people you have in a previous generation, right? You could have aunts, uncles, all kinds of other relationships. Now, the most successful previous generation I tend to find is in the area of first cousins and second cousins to your parents. Because often, especially in large families, what happens is there's a big generational gap between, say, the first child and the last child, which means there could be a huge gap between the first set of first cousins and then the last set of first cousins. So many of us even have our parents' first cousins that might be our age or slightly older. And so when you're looking at the previous generation, look all along the generation. Might your parents have any first cousins or second cousins and so on that might be alive? And those are going to be excellent candidates for testing in that previous generation. Now, of course, if your parents are alive, that's obvious. Test your parents. But don't look past the other relatives you might have in that particular generation. Now, if you have no vertical generations or you've exhausted that generation by testing those individuals, then you can test horizontally. Right? And so anyone in this horizontal generation. So at that point, for example, now your siblings might be useful in this particular example. If I've tested my parents, for example. So what I always say about my siblings is my siblings are useless to me. Because the universe of DNA I can get by testing my siblings, I've already tested by testing my parents. However, if I hadn't tested my parents, my siblings would be among the very first people I would ask to test. So who are the type of relevant relatives that you can ask to test in that horizontal generation? Well, certainly you, but then your siblings, because you're going to share all of your family lines with your siblings. Now, when you talk about first cousins, for example, you're going to share half of your lines with a full first cousin. So obviously, again, excellent people to ask to test if you can. Then there's second cousins, and you share 25% of your lines with a second cousin. And so these are all excellent people to ask to test. Now, again, if you have no living first cousins, no living second cousins, there's no reason you can't go down to the next generation, right? You can go to nieces and nephews, or you can go to a first cousin once removed, your first cousin's children, or second cousins once removed. All of these are examples of individuals that are going to share lots of DNA with you and give you insight into things like shared match groups, and so on. So these are all people that you can test. But you really want to focus on that previous generation, if at all possible, even going out as far as first and second cousins and asking them to test. And then focus on your horizontal relatives. Okay? So, for example, maybe this is what my genetic family tree looks like. All right? And so if I tested DNA to examine one of the ancestors in white that I didn't get DNA from, that's an unfortunate outcome for me. On the other hand, if I ask my sister to test, she might look like this. And in fact, together, I think of it as catching more DNA from the ancestors. We're catching more ancestors in our net, in our DNA net. We're catching more DNA from those ancestors. So if I overlap my sister's genetic tree and my genetic tree, it might look something like this. And in this case, rather than having all of these missing lines from our DNA, now we only have a couple. And maybe if I can ask a third sibling to test, we might actually be able to say we have DNA from all of these lines. Now, of course, the real problem is we don't get charts like this yet when we get our DNA results. Someday, but the thing is you know, the science says by testing these siblings, you're capturing more DNA from these lines, and you can take advantage of that. So another way to visualize it is like this. So this is sort of the concept of DNA coverage. And I think Paul Woodbury puts it best. It's the amount of a research subject's DNA that's represented in a database through their combined tested descendants. Right? So essentially, the more DNA in the database from a particular ancestor, the more DNA evidence we're gathering about that person. And certainly testing individuals in either a previous generation or your own generation, or even the next generation, is going to improve that DNA coverage for usually all of your ancestral lines, but importantly for whatever ancestral line you're interested in at the moment. Okay, so you're going to get improved DNA coverage, more DNA from ancestors by testing more family members. So here's a quick example. If I test myself, the coverage of me is 100%, right? I'm getting 100%. If I'm testing myself, I'm getting 50% coverage of each of my parents. If I test myself, I get about 12.5% of my great-grandparents. But if I add in a sibling, I'm getting about 75% coverage of each of our parents and about 20% coverage of our shared great-grandparents. So adding in just that one sibling really boosts that number. Right? So here's another visualization of this concept of DNA coverage. In this example, we have a grandparent, and the grandparent has 4 grandchildren. 3 of them through a son and 1 of them through a daughter. And the question is, how much of the grandmother's DNA can we capture by testing all of the granddaughters here? Because that might be our research focus, right? Our research focus might be who was grandma's biological parents. And certainly the more DNA we have from grandma, the easier we can answer that question. Or maybe our goal is simply to map these pieces of DNA. Or maybe our goal is to determine things about the life, the biology of the grandmother. All sorts of goals for doing this. But if we look at this, this is a comparison between the grandmother and the one granddaughter. Now, this requires the grandparent to be tested, so I'm just showing this as an example. Imagine in most cases you're not going to have the grandparent, but you're going to have this same process occurring. This is granddaughter 1. Here we have granddaughter 2. You can see there's differences in the pieces of DNA they get from the grandparent, and that's to be expected. Then we can get granddaughter 3, and we can get granddaughter 4. Okay, so we have all of these 4 grandchildren, and when we combine them, we get incredible coverage of the grandmother's DNA by testing these 4 different grandchildren. So the more descendants from your target ancestor that you test, the more DNA you're going to have from that individual. And then the more DNA you'll be able to map, the more shared matches you'll be able to utilize, and the more information you're going to be able to gain. So we might go from something that looks like this to something that looks more like this by testing those individuals. Okay? All right, so this is just an example of why you want to test those other people. Here's another example. So I've tested myself and I've tested my sister, and this is a list of shared matches between my sister and I, and you can see there are huge differences in the amount of DNA that we share with each of these individuals. So let's take that first one, for example. I share 106 centimorgans with Ronald, and my sister shares 78. On the other hand, if we look at the bottom one, Laura, I share 36 centimorgans, and my sister shares 93. And so she potentially is getting more DNA that she shares with that individual from whatever ancestor I share in common with Laura, and vice versa for Ronald. So having that sibling testing gives us a lot more opportunity for using the results and things like mapping and shared matches. Okay, so testing multiple relatives on different lines gives us lots of opportunities for finding new shared matches and using that information. On the other hand, when it comes to targeted testing, this is more of a focused approach. In the other one, we talked about testing multiple people on different lines, and that's essentially in the hopes of finding them in things like shared match groups to give us more information. Here, I'm thinking of examples of where we want to answer a specific genealogical question. Who was the mother or father of this person? Am I descended from this person, for example, or maybe from that person? And the thing is everyone in this room has their own unique, different focused research question. So what I want to do is give you some ideas about approaches here for targeted testing that can examine that specific research question. Here's one that I think is interesting, and that is testing to explore DNA gaps in your genetic family tree. The more people we identify amongst our matches, the more we can identify lines for which we have DNA evidence. And I think that's one of our ultimate goals, right? To find DNA evidence for each of our family lines because it adds another piece of evidence to our genealogical conclusions. I think of it as finding a new record source, right? We've worked on these families, some of us for decades, and now we have this new evidence source we can add to it, and if we can do so, we certainly want to do so. So here, for example, this might be a genealogical family tree, And when I looked at this, I was asking, what lines do I have DNA evidence for in this particular tree? And so I highlighted those. I believe I have DNA evidence for all of the lines that are highlighted here. And how is that based on? That's based on finding a match that appears to be descended from the same family that I have highlighted here. All right? What that means is I can now target holes that I have in my tree. And what I mean by that is individuals I've identified, but I would like to find DNA evidence to support that individual in my tree. So I can take any one of those lines that aren't in yellow, and I can potentially try to find matches that are through that line. So if I take this particular family here, that is Edith Ellis, for example. If I take this line, I can see that Edith Ellis here married James Henry Cowell, and they had a number of children. Now, I'm descended from their youngest daughter, Laverna. So what I can do here is I can find other descendants of this family and ask those individuals to test. Now, of course, this can be very complicated from jurisdiction to jurisdiction, right? So things like privacy laws, access to records, availability of records, existence of records, those all could be barriers to tracking this family down. But if I can contact other people that are interested in this family, for example, they have a tree up that has this family, or they're posting on message boards and things like that. This is identifying other people that have made themselves known through this, and I can contact them and I can ask if they're interested in doing DNA testing and potentially adding that DNA evidence onto this particular line. So whenever I can do that, this is a form of targeted testing, right? Finding another descendant of a family I'm interested in and asking them to take a DNA test to provide that type of evidence. So where possible, I can track these descendants down, or, right, don't overlook the people you're already matching. One thing you can do is search the database of your DNA matches to try to find people that are already, it appears they're descended from this particular family. Now, what's one of my issues here? One of my problems with this particular example is the descendants of these other children here are going to be around fourth cousins. But my other issue is that if I find a descendant of James and Edith and I ask them to test on another one of these lines, my problem is I don't know whether I'm really confirming the Ellis line or the Cowell line, right? Because a shared piece of DNA could have come from either of those individuals. So one thing I can do is if I really want to focus more on the Ellis line, rather than really just confirming my relationship back to Laverna, I can go back another generation, right? I can go back to Edith's parents and siblings, follow those lines down and ask those individuals to test. And if we share matching DNA and we can further do that, document the relationship, then that adds DNA evidence specifically to the Ellis family. All right, so look at the family you're interested in. What line do you have where you haven't found any matches, and test those individuals. Now, as you're doing this, always keep in mind the fact that the reason you might not have matches to this family is because you're not a descendant of this family like you thought you were, right? And there's always the possibility that the research is incorrect. Obviously not us, but for other people, maybe the research is incorrect, right? Or there's the possibility of a misattributed parentage event where the genetic parent is not the parent on paper and so on. There's all these possibilities. But targeted testing gives you additional evidence to try to make those analyses, try to reach a conclusion about whether or not you actually are descended from this line or whether you think there might be an issue. Obviously, in order to reach that conclusion, you have to have enough evidence to analyze it. Another big use of targeted testing, and probably my favorite, is to force the creation of a shared match group. So when we force the creation of a shared match group, we're harnessing the power of shared matching to point towards a particular line. And so shared match groups can point towards specific unknown ancestry if we test the proper descendants. So I think of shared match clustering, of pointing towards particular ancestors. It's really just a new way to organize your matches. Because what you're doing is you're trying to identify from a list of however many matches, 5,000, 10,000 matches. You're not creating new matches when you form these shared match groups. What you're doing is you are plucking out of your list the matches that are important to your particular research question. So really what it's doing, it's just taking and it's reorganizing your information, your match list, in a new way. You can extract new clues out of it that you couldn't do before. So here's an example, and I use this one a lot because this is my most frustrating brick wall. This is my great-grandmother. She was born in 1889, died in 1983. Her parents are a brick wall. And so what I want to do is I want to use shared matching and targeted testing to point towards her ancestors, essentially to pluck the right matches out of my match list that are related through her and will give me clues about her biological ancestry. Unfortunately, if I just look at my match list, right, that doesn't point. I don't pluck individuals out by finding people in my match list. Now, there are ways you can go about this, essentially the process of elimination. But what I'd like to do is I'd like to get an even more focused approach, and that is by forcing the creation of a shared match group that will do just that. And the reason my matches don't point towards this particular family is because we're only looking at one line out of 8. So I'm going to have all of these matches, thousands of them, that are through each of these individual lines, and it's going to be tough for me to say this is a match through this line and so on, right? Particularly as they get more distant, we know this gets more and more complicated. On the other hand, if I can force a creation of a group that I'm particularly interested in, then that will allow me to pluck out those matches. And here's what I mean by that. So here is essentially my situation. A little simplified, but we have my unknown great-grandmother. I would like to know, she's known, but her biological parentage isn't known. So what I'd like to do is I'd like to be able to identify which of my matches are through this particular line. So what I've done is I've tested 2 descendants of this ancestor, and what that does is that forces the creation of a shared match group. And so if I talk about the shared matches between me and this individual would be a second cousin here. If I look at the matches I share with that second cousin, where does the DNA and the shared matches come from? The DNA and the shared matches that I share with this second cousin can only come from 2 places. They come from either the known great-grandfather or the unknown great-grandmother. Now, there's a little bit of an assumption there. The assumption is we're not related some other way. Because if we have multiple relationships, the DNA and the shared matches could have come from either of those multiple relationships. But here we're going to at least assume that this is our only relationship. And the more you know about your tree, the more you'll be able to look and consider that possibility. But if I have a bunch of shared matches that are essentially presented to me on a platter by testing this known second cousin, then I only have 2 groups. I have to eliminate the shared matches that are through the known great-grandfather, but as long as I have information about his tree, I can do a fairly good job of eliminating at least the close shared matches that appear to be from the known great-grandfather. What that will leave behind is it will leave behind a bunch of unknown shared matches, presumably from the unknown great-grandmother, and then I can focus on those to point towards the ancestry that's relevant to my unknown great-grandmother. So what have I done? I've created a focused group of shared matches by testing another descendant of that particular line. Now here I'm using it for a great-grandparent. You can go to great-great-grandparents and further back. However, the further back you go, of course, the more complicated it's going to be for a number of reasons. Just because you're getting less and less DNA from that generation, fewer matches from that generation, greater possibility of multiple relationships. But that's why the further back you go, you don't want just a 2 people testing. You would want multiple descendants testing. And then you can do shared match pairwise comparisons between anyone in that list of tested individuals. And every single one, hopefully, will pick out, you'll get a new shared match here that's relevant, a new shared match here. And with enough of those, you'll start to recreate enough information that you can look at to try to find that unknown ancestor's biological line. And so what I did is, as I said before, I created that silver platter. And how did I create that? I simply tested the proper individual. So that's that targeted, focused testing I was talking about. Right? And I didn't magically get a whole bunch of new matches, right? My match list is still the same, But what it's done is it's reorganized my match list. It's plucked out the relevant matches that are important to my particular research question. So these shared matches point towards the proper individual. And what will I do when I get a list of these shared matches that I share in common with my second cousin? Well, here's an example, right? These are all shared matches I share in common with person number 2 here, my second cousin. So remember, what's the hypothesis? That these shared matches are related to me and my second cousin through either the known grandfather or the known great-grandfather, the unknown great-grandmother. And if I can eliminate any of these as being on the known great-grandfather's line, then I have a list of matches that are relevant to the unknown great-grandmother. Now, this is a real-life scenario, and when I do this, certainly I do get some really good matches that are to the known great-grandfather. But I can just eliminate those for now. They're really great evidence and groups to have down the road when I'm focused on that line, but instead what I leave behind are some really good matches. And in fact, when I did this several years ago, the very closest match I didn't recognize, sure enough, when I built out their tree, I found that they had ancestors that lived in the exact town where my great-grandmother was born. Right? It's a very small, tiny town. So the odds of finding that shared match in between us and then finding that they had ancestry in that small town are very, very small for that to be random. What happened instead is I was able to pluck out this very important match by target testing the proper person and forcing the creation of these shared match groups. So when I find a shared match like this, what I'm going to do is I'm going to open the trees and I'll review them for hints. I'll review them for surnames in common. I'll look for families in common, locations in common. And note, when you're doing this process, you're certainly going to have to do a little bit of building the trees for your matches too, right? Because many of our trees have incomplete trees or no trees. So the more tree building you might do for your matches, the more you're going to be able to take advantage of this process. So what did targeted testing do? Targeted testing allowed us to point towards the most relevant matches. And that was for a very specific research question. Now, on the other hand, we talked also about the broad testing, which is good for simply hoping that when you test and you check for shared matches with that new match, John Doe, up shows a known match, and you can formulate those 2 hypotheses. The first hypothesis is always the instant one, and that is we are in a shared match group because we share common ancestry. And then the second hypothesis is dependent upon finding that relative in there, and that is that this is likely what our shared line is because the known match shows up. Now you'll note I used the word hypothesis. I probably used it 50 times in this lecture, and that's because we aren't getting answers here, we're getting clues, right? Finding a known match in a shared match list is a clue. Finding that person in the shared match list that targets towards a particular line is a clue. It's up to us then to incorporate the the traditional genealogical research and then to ultimately come to a conclusion. I just want to emphasize it's really important for us not to jump to an automatic conclusion just because we might get this one piece of DNA evidence. It's always, in DNA and genealogy, it's always about all the evidence put together to reach a conclusion. All right, so I know that we probably didn't get to your specific example of why you might do a targeted testing plan, but as you're doing this, think about who might be in that previous generation, including cousin level, that you could test. Who are good people in your own generation? And if you have a specific genealogical question you want to answer, look at that and say, can I create shared match groups that will point towards the best matches in my match list? So with that, we will answer some questions. Yes, right here.
Well, for force the match group, it sounds a little dramatic. How do you force people to DNA test?
Oh, well, of course, we don't force people, but that's always the limitation, right? I was lucky. I asked that second cousin to test, and she said yes. Now, of course, when I ask someone to test like that, there are a couple things I do that try to encourage them to test. The number one thing, of course, is I offer to pay for the test for them. Because if I really wanted these results, and so the more I want the results, the more I'm willing to pay for that test, right? Maybe less so when you're talking about maybe some of your horizontal line relatives. For vertical, those, again, are people I really want to test, so those would be people I'd really want to do that for. So that's always going to be a limitation. I've certainly had people say no, but thankfully, it's a lot easier to ask today than when I started in the mid-2000s. Back then, DNA testing was a little bit more off the wall, whereas today it has much more acceptance. Good question. In the back there.
Yesterday you said you didn't like to use Excel, but where do you paper and pencil software, where? The other question is, I've found second cousin twice removed, which I know is in my tree, and his grandmother,
You shared great
my grandfather's sister was his great ancestor or something, but
Yep.
I don't know if it'll lead to my great grandfather or my great grandmother, right?
That's all right. So I'll answer your first question. Your first question is, how do I keep track of this information? So for me, I'm typically keeping notes in a running document. So it's a running Word document, some type of document like that. And so I'm trying to organize the information and keep track. I'm also, however, keeping notes in the notes field at the testing company. So I would want to make sure, because when you use shared matching at MyHeritage, for example, you'll be able to look at the notes field of those shared matches, and that will give you clues about your relationship. As to your second question, with that second cousin twice removed, you share your set of great-grandparents, right? So the DNA you share with a second cousin twice removed, those pieces, some of them are likely to be from your great-grandfather, some of them are likely to be from your great-grandmother. And so certainly by testing that second cousin twice removed and looking at the shared matching, some of those shared matches will be to your great-grandfather, and some of the shared matches will be to your great-grandmother. It'll be up to you to try to figure out which is which, right? And the more you know about one line or the other, the more you'll be able to use, say, process of elimination. Any other questions? Okay, then with that, we will end there. Thank you very much.